Hi everyone, welcome back. Today we're going to try to do the nested chain rule example. So applying chain rule to slightly harder problems. So first let's recall what the chain rule actually is. So the chain rule is when you have to take the derivative of nested functions. So what the formula for that, what nested functions actually mean is when you have functions within other functions. So what the formula looks like is you have d dx of f over g of x is equal to f prime g of x multiplied by g prime of x. So what this shows is you have your outer function, you have the f of x, take the derivative of just the outer f of x, keeping the inner one the same. Then you multiply it by the inner function, g prime of x. So that is the generic chain rule formula. Now let's apply it to a slightly more difficult problem where we have multiple functions nested within each other. So our example will have, we need to take the derivative dx, there you go, of y is equal to 5x squared plus the square root of 3x cubed plus 1 raised to the 7th. So again, before we go in, let's just take a breath. The whole point of calculus and the chain rule is to simplify difficult equations such as this. So let's try to see if we can separate outer, inner functions. So let's see, we have this outer function right here, which can be rewritten as something raised to the 7th, right? So this is your outer function. Then we have an inner function right here, where we have 5x squared plus square root of 3x cubed plus 1, right? So let's rewrite the outer function. So instead of saying something to the 7th, we're just going to say u to the 7th. And u is equal to 5x squared plus square root 3x cubed plus 1. So it's just the inner part. So let's start by taking the derivative of the outer. So we have, so dx of u to the 7th is equal to 7 u to the 6th du dx. And it's very important to apply this du dx because it signifies that we still need to take the derivative of u, and u itself is a separate function. So, but for now, this is our outer. I'm going to put a little prime up there, our first outer thing. Now, let's take the derivative of the inner function. D dx of 5x squared plus the square root 3x cubed plus 1. But now let's wait a second. We notice that there are two different functions within here, right? And we have the 5x squared plus the square root 3x cubed plus 1. So let's first separate those into two derivatives based on the addition rule. We have d dx of 5x squared plus d dx of square root 3x cubed plus 1, right? So these two statements are equivalent. So the derivative, actually I'm going to go back, I'm going to put a little circle around this just so that I can see it easier later. So the derivative of 5x squared is just equal to 10x. And then let's try to take the derivative. I'm going to circle that. That's a term. And then the derivative of square root 3x cubed plus 1. Now, this is a little tricky because this is actually another function within a function. Because this we can rewrite as 3x cubed plus 1 to the 1/2. So, because we have this, we have to apply chain rule again. So, now we have the outer function, and then we have the inner. So the outer function, I'm going to go back to blue. So we have outer is just the something to the 1/2. And I'm going to say this something will be v. So I'm going to say v to the 1/2. And then we have the inner, which is just 3x cubed plus 1. So applying the chain rule formula, which is the derivative of the outer times the derivative of the inner, we have, how do we write this? We'll have 1/2, so this is the outer. We have 1/2 times v, which is just the inner. Oh, my bad. I forgot the plus 1 there. So v is just the inner. So 1/2 times 3x cubed plus 1, right, to the minus 1/2. So the reason this is minus 1/2 is, again, power rule. Bring it down to the front and then subtract this by 1. So 1/2 minus 1 is negative 1/2. Then we multiply this by, and then let's go to the inner one, sorry. So the inner function, which is 3x cubed plus 1, so the derivative of that would be 9x squared. So the total derivative of this term, so derivative of square root 3x cubed plus 1 is equal to 1/2 3x cubed plus 1 to the negative 1/2 multiplied by 9x squared, which equals, and we can rewrite this as 9x squared over 2 square root 3x cubed plus 1. So just how we got to this is this first term right here has a negative 1/2. So immediately the negative brings it back down to the denominator. The 1/2 stays, so this 1/2 is right here. The 3x cubed plus 1 is now in the denominator, and it's negative 1/2. So 1/2 is just the square root. 9x squared is on top. So now let's combine all the terms. So we have, and I'm going to circle this as the third term. So these two terms, right, the 10, oops, the 10x and the 9x squared over 2 root 3x cubed plus 1. Now, instead of making this multiplication, we have to go back up, and we notice that we did the addition rule right here. So we actually have to add them together. So we're going to add them, and I'm going to leave it in blue just to kind of signify this because this is all one term. And then we're going to multiply this by the original outer, which is 7u to the 6. And remember, u is the original um, inner function, which is 5x squared. 5x squared, and I'm pretty sure, yeah, plus 3x cubed plus 1. Plus 3x cubed plus 1 square root of that. All to the 6th, because 7u 6. And this is our final answer. That is the derivative of the original function, which was this right here. There you go. So this derivative is equal to, oops, is equal to that. Hopefully that cleared some stuff up, and I'll see you next time.